And first I'd like to say thank you very much for the opportunity to come talk to you. We do this regularly with Lawrence Tech, and we usually do it at our facility. Professor Reamer brings over a group of students and we're able to walk through and look at the technology. I'm going to try to describe that the best I can today. It's a little easier when you have the actual items with you. But entrepreneurship is it's a very important aspect of what we do in our business today. Yes, you can do it individually, and that helps you create your own business and things like that. But as far as corporations, it's very important to corporations because, after all, that's where the ideas come from, and that's where the products are developed that the corporation is going to sell. So before I go through and go through a couple of slides I have, I just want to make sure that you all understand that company and technology and what they have to offer their customers is what business is all about. And without having individuals within the corporation being able to be or have the freedom to identify ideas and develop different types of technology within the scope of the corporation strategic plans, that's what makes that business grow. And automotive industry is an excellent example and an excellent industry for that to take place. Okay, what I'd like to do is start with what we do at Lear Corporation. Before anything is developed, what we do is we have a method called PVI, and it's a way that we interface with the ultimate customer, not only the OEM but also the consumer. And the PVI method is a plan or a path that we follow where it's for people, how the people integrate with the vehicle, and that's where our ideas come from. The first part of the PVI method is our consumer market. We do a lot of research at Lear Corporation with not only the OEM customer but also the consumer, the end-all user. What type of ideas or what type of options that they look for in vehicles, what type of options specifically would they like to see on their seat systems, and what are the pros and cons of those options. The next thing that we like to do, following the PVI method, is the benchmarking activity. And what we do is we go through the different automotive segments, and we actually go into the vehicle and describe what different types of attributes are within that vehicle. And then we take that segment series and go through and match up all the vehicles in that segment and take readings of what they offer as well. So for instance, on a benchmarking activity, we'll look at the width of a seat. Okay, so if you're going to have a sedan, a mid-size sedan, for instance, what are the overall widths of those seats? What type of power options are accommodated on those seats in regards to, does it have a power track? Does it have a manual track? Type of recline system, headrest, armrest, and those different types of attributes. Does it have an entertainment system that we can put in? Cup holders and different things like that. Then what we do is we establish what type of ideas that we want to go forward, and we put those into an industrial design. So you're taking an initial concept that you want to build around, and you actually get a picture of it, or you make a picture of it. And that helps you start to create what the work plan is going to be, what this thing is actually going to look like, and then how it's going to interface with the consumer, and also it even starts the ball rolling with how you're going to produce the thing within the manufacturing and those types of requirements. Then what we do is we look at different technical analysis of components. All right, what are the key attributes of those? You know, it's not only just the size, but what are the validation requirements? It's very important. And what does this particular item have to meet? So that's a very important part before anything is developed. And then again, like I said just a minute ago, the manufacturing process is the key. And that's one thing that I stress to all engineering students, is manufacturing process is one of the most important things that you need to understand. Because if you don't know how different components are manufactured, how do you design them? And you need to understand what are those key attributes when you go in and actually have the components made. And it's not just like making one part. You have to understand how that component is going to be made time and time again. So the repeatability of that product, what's going to be key in that type of product that's going to sustain the quality and the satisfaction that, after all, that you're trying to build into that product. And then finally, what you do, or what we do, is we look at validation. What are the specific types of tests that are going to be required in that type of component that you want to build? So again, before any item or product is being developed, these are the different steps that we go through to get the ideas. And it starts out as a white sheet of paper, and then we build on it. So we find out what the consumer wants, we benchmark that type of product, and then you validate it, you look at the type of manufacturing, you get a picture of it, and then you go forward. Okay, then what we do at Lear Corporation when we develop a product, we have a system that we call, it's the Invent system. And the objective of this Invent system is, first of all, to develop and deploy a tool assessing strategic opportunities for growth through innovation. And again, when we develop products, we have to make sure that they fit in with what the corporation's strategic plan is. Because after all, anytime you're going to build something, whether it be an individual or a person within the corporation, you have to get funding for it. And the only way to get funding for it is you have to be able to lay out what your strategic plan is going to be. Okay, so the first phase is to understand what the strategic plan is. And then you develop a forum to review those strategic opportunities. And that forum is going to consist of many different aspects. If you're an individual, it could be the people that you're working with to develop. It could be yourself. It could be your financial institution. And it could be your benchmarking activities or whatever you're doing. Within a corporation, I'm going to go through and show you another slide, all the different aspects within the corporation that tie into the business strategic plan of what you have to go through to be able to get your idea up and running. And then, again, it's all about getting the funding, so then you have to approve and fund the advanced project to meet the strategic opportunities. So in the events program that we have is, first of all, we look for the initial proof of the concept. Okay, that goes back to the PVI method. All right, did you do your benchmarking? Did you do your technical analysis? So you have to understand and prove out what you're going to do with your concept as you start to build the plan to make a particular component or invent some type of technology. Then what we have to do is we have to verify what type of tools are going to be made to make that component. What are the prototype tools? How are we going to make the initial concepts that we can take forward to the customers and show them the type of ideas that we're looking for? And then we have to enable for the customer and the testing. So what are the enablers for the customer? What is the customer going to get out of that, and how are we going to verify to that customer that those products are going to meet within the required validation? And then at the end of that, you have to figure out how you're going to sell it. Okay, so that's the next point is, once you've developed an item or come up with a technology that fits within a strategic plan, how do you go about selling it? And what are the key points that you're going to be able to take forward? And then before you get into the customer, you have to make sure that you've got your internal reviews done. You got to make sure that you understand exactly what you're trying to pinpoint with the type of technology or product line, and go forward. So you have to have it. We have internal reviews. Then we have the design for the customer readiness to be able to go in and review what all the aspects are of those designs, and again, prototype, and then figure out how much it's going to cost. Now, that whole process takes about 14 months. Okay, so when you develop a technology, there are times that things are much shorter, and you have to develop a particular item quick to market where you don't have the liberty of 14 months. But normally what we try to do is we develop a particular item and go through these steps. It takes about 14 months. And again, the aspects that we deal with within the company is, again, manufacturing we interface with, purchasing we interface with, cost estimating, and then also the sales department. Okay. When you go through and you develop the innovation process, I told you a minute ago I was going to go through all the different aspects. Now, this is in regards to the corporation. Like, for example, in Lear Corporation, these are the different aspects: advanced sales, platform teams, advanced engineering, the strategic objectives of the corporation, consumer research, and business development. Those are all part of the innovation process. And they're a key part of the innovation process. And then at the bottom part of this particular chart, it shows what you're doing as far as evaluating the market, what's going to be the corporation's position. You identify what type of strategic gaps there's going to be, evaluate the product strategies, and evaluate the other advanced projects. And you need to have all that information so when you go forward to get the funding, which is the most critical part of developing products, you have all those answers. Now, really, the best way to do that is you look at SWOT analysis, and I know everybody has done SWOT analysis, but you really need to understand and have exactly what your objective is going to be and how it interfaces within the plan, so then you can go forward and get the money. Now, I've talked a little bit about, so far I've talked about how Lear goes through and giving you some ideas of the different types of processes that we have. Before I start to go through I brought some ideas of the types of technologies that we develop. The thing that I really want to get to, and what is described in the pamphlet, what this is all about, is entrepreneurship as far as individual versus corporation. The individual part's easy because you want to start your own business, you come up with ideas. Okay, but in a corporation, like I said in the beginning, it's very important that the company has people that are individualized from the standpoint that they have the freedom to develop products. So the key point is just because you're in for instance, Lear's a $14 billion corporation. Just because you're in a $14 billion corporation does not mean that you don't have the ability to develop technology. And we give the latitude to our employees, and it's not just engineers. It's all the employees that can work on a cross-functional team, or if they have an idea and they want to bring it forward, we have different forums where we're able to do that. And that's how we develop our technology. So it could be as simple as you're going to come up with an entertainment system. It's not just an engineering focus. You're going to go around and you may ask people, other people within other groups of the corporation, hey, I'm developing this entertainment system. What do you think? Or do you have children? What do your children's? What are their interests when they look at an entertainment system? And then those people can become part of that cross-functional team and help build that technology. And then when it's time to go and file the intellectual property information, that person is also part of that. So the people that receive patents within Lear Corporation aren't necessarily just engineers. And the reward, we also have a monetary reward that goes along with our intellectual property program. They also receive monetary awards. And what those are for is to create or to keep the open mind and to keep the ideas flowing, basically, to create different ideas and to develop the technology. Okay, now what I'd like to do is I want to go through some of the products that we've developed. Okay, here's a particular product that we've developed. It's called an active headrest system. We call it ProTech. Now, this system was originally developed in 1998. This system also has over 21 patents associated with it, and there are still 11 patents that are pending. Okay, this was developed from a team of individuals at Lear Corporation, and originally what we wanted to do was develop a product to help out with whiplash injury. Okay. In fact, we were so successful, we were able to reduce whiplash injury by 43%. Now, who knew that the federal government in next September has regulated that the vehicles have to have a headrest that protects whiplash? Okay, so here's something that was started in 1998, for instance, and we've developed it over those years. It's on over 6 million vehicles today that goes in and meets the FMVSS, the Federal Vehicle Motor requirement. In addition, reducing whiplash injury by 43%, and also meets a good rating with the Insurance Institute. Now again, these were individuals that developed this. The corporation did not say, hey, we want an active headrest. What we developed from the individual side was, hey, I'd like to go out and develop an idea that can protect the driver. Okay. Another particular item that goes along that same type of line in regards to safety, what we've done is we've developed a technology that we call haptic. And what we're doing is relying on a sense. Okay, this sense happens to be feel, where we integrate a seat system within the vehicle architecture of the electronics, and where if the vehicle finds an issue, like you're too close to another person in front of you, or you start to veer out of your driving lane, the seat starts shaking. And what that's supposed to do is alert the driver, hey, something's wrong. Now again, here's something that an individual team has put together. The corporation didn't come out and say, hey, build this. Not only can it be used in the automotive market, but it also can be used in the large truck market. Okay, so it's a very successful item that we're taking in the future, because there's a lot of different things now that are being developed in vehicles. For instance, your outside mirrors on your vehicle look for blind spots. And that technology is coming forward that if somebody's in your blind spot, something starts flashing or it alerts you somehow. Well, one of the alerts can be tied back to the seat system. Okay, another item that was developed was, we all know how important the environment is today, and our dependency on petroleum oils and different types of ecological aspects that we're looking for. We've created a system called DEX. And what the Dynamic Environmental Comfort System does is it allows us to do a layered approach of different items. So there's actually multiple things in here that can be patented. And we're bringing that forward into the new vehicles that we're putting seats in today. For instance, soy foam. I don't know if you've all heard about soy foam, but Ford released soy foam. That was something that was patented between Lear Corporation and Ford Motor Company. Okay, and what the idea behind soy foam is to get rid of the petroleum base in the polyol mixture in the polyurethane foam. Okay, we replace a certain percentage of the petroleum oil with soybean oil, and so it was originally released on the Mustang program. One program that has roughly 100,000 vehicles to it saves 40,000 gallons of oil a year. Lear makes roughly, well, when volumes were up, we make, I forgot what we make, how many seats we make a year. Yeah, we make 250,000 seats a day worldwide. Okay, that's a half a million barrels of oil a year. So that's pretty substantial. And it's something that was an idea that was originally invented by, investigated by Henry Ford. And because of all the issues with the gas prices and the oil and things like that, it's now coming to the forefront. And like I said, it's individuals that came up with an idea that said, hey, we can go out and we can work on this particular project. In addition to the deck system, we have an item where we replace some of the steel within the frame of the seat system with structural foam. And that allows us to obtain a very lightweight system, put the structural foam where we need it, and reduce some of the steel cost. And then within the trim system, we have different items where we make fabric out of corn husks. And those are different items that individuals have come forward to and developed that technology within the corporation. Another idea that we developed, and we developed this a few years back, that happens to be on probably 18 million vehicles at this point in time, the Lear Flexible Hardware System. And what this type of a system is it's a flexible system that uses common components. And what the ability for this system does is we can go to our customer base and say, look, you don't have to keep redesigning the frame system. All you got to do is tell me what your width is and we can make it larger or smaller. And we've got an idea that not only can save you money, but it saves design time and you can go faster to market. So here's another particular item that was designed and developed by individuals within the corporation and have taken that forward. Then we've got some of our futuristic seating, pedestal seating that we call it, which are going to be very important within the coming years because of hybrids. Hybrid technology, I'm sure some of you have worked on some hybrid projects or at least have been exposed to some of the hybrid projects. In hybrid vehicles, you need room for different things. If you're going to have an electric car, you need to have some type of cooling system. So there's going to have to be some different area that you're going to have to put other components within that vehicle. And pedestal seating allows you to gain some better access to different clearance within inside that vehicle to put those different systems in. Okay, now one of the things that we do when the students come over to Lear Corporation is we take them down the walk, the patent walk, where we have the walls of different plaques of different ideas that we're able to go forward and show that here are individual plaques by employees of Lear Corporation and the different ideas and technologies that they've developed. And this gives you an idea. And now these are all individuals within the large corporation. For instance, the disclosures. So the ideas that have been presented for intellectual properties in 2008 were 201. Applications actually filed, because there is a process, you have to go through that process and understand, is your idea valid? Does it infringe on any other type of technology that's out there? Because you don't want to do that. So if you get an okay that you're good to go, we had 195 of those in 2008. And in 2008, the total pending applications were over 534. Now, the process takes a while. You just don't put your information in and get it back in about 6 months. It can take up to a year or sometimes even longer. The patents that were granted in 2008 were 56. Okay. Today, total Lear Seating's patents that have been issued are 455. And then in addition to intellectual patents, we also have confidentiality agreements that when we develop technologies, it's not just within Lear Corporation, but for instance, we developed soy foam with Ford Motor Company. We have confidentiality agreements with a whole bunch of different organizations, and there was 543 of those. So you can see that there's a lot of activity in intellectual properties, especially within Lear Corporation. But that's the key, I guess, of what this is about. I mean, yes, you can be an individual, start your own business, and you can create different products that you want to take to market. I'm not sure that's the majority. I think the majority are going to work within corporations. And from that aspect, Lear is just like any other type of corporation where, especially within the automotive industry I can speak of, has a system that you can develop intellectual properties. And for that to happen, it's individuals that do that. So at this point, that's what I have as far as the presentation. Now what I'd like to do is ask, and I know everybody's going to say I don't have any questions. Do we have any questions? Okay. Yes.
You know, so when an engineer or someone comes up with an idea, and I saw that timeline, you got 14 months, it's going through the PBI and everything. Is it a matter of them working on it aside from their normal workload, or on their after hours, or how does that work?
No, that's a really good question. No, it's not. Sometimes it is after hours, but most of the time, you're developing a technology, for instance, that's like I said, is part of the strategic plan, and that is tied to some type of program. When you get funding to work on an idea, within our system, you're doing it toward a program, because you're ultimately, at the end of the day, you want to be able to sell that technology. Okay, so no, it's not after hours. It's during work that you develop these ideas. But I mean, you can definitely after hours look at different items that you want to work on. But again, it has to fall within the guidelines of the company if they're going to pay for it. But no, it's part of your job. And to have the cross-functional teams and to get together and review the types of different ideas that you want to build this technology around. You have team meetings, or, and the team can be one person. We have a multitude of patents that are just single-person patents within the corporation. But again, we also have team patents as well. And everybody on that team gets a plaque, shares within the monetary reward, and you're recognized for that. Okay, good question, thanks. Any other questions?
I don't know if you're at liberty to say this, but what are some of the really hot topics that you're working on now?
I mean, I can tell you that. One of the, safety is always a hot topic. What are we doing in regards to safety? And safety comes about not only because we want to develop a type of technology that we can go to our customer and say, hey, you can add this to your vehicle for this type of benefit, or there's actually a requirement that's being developed. Like I said, when I went through the ProTech, the active headrest, that's actually a requirement now. So even though that we were working on it many years prior to when it became a federal requirement, it's something that is being mandated. So you have to develop technology that's going to meet those requirements. Hybrids are a big force right now. So what can we do within our seat systems to, number one, get the room that's required for what that hybrid system's going to have to utilize, and number two, how do you make that seat system lightweight? After all, if you can reduce the mass of an overall vehicle, then you can save on fuel. So environmental is a key. Flexibility for the end consumer has always been a hot topic. How do you take that interior of that vehicle and allow the consumer to be able to manipulate the seat systems within that vehicle to meet whatever needs that they have? So for instance, if I'm going to go to Home Depot and I'm in a sedan, but I got 2x4s I bought, so what do I do with the seat system? So I can accommodate that end user, because not everybody's going to have an SUV. So those flexibility within that seat system is a very hot topic. I've talked about the lightweight. Well, it goes along with the lightweight are the different materials, carbon fiber, development of carbon fiber, what we do with aluminum, what we're doing with plastics. How do we make plastics that are environmentally friendly? Can we put corn in plastics, things like that? So does that answer your question? Okay. All right. Any other question? Yes.
You individually, you graduated from here, but obviously you're in a completely different role than what I'm assuming you started off with when you graduated from here. What were the steps to get to the position that you're in now?
Yeah, that was a good question. You're right. When I graduated, in fact, before I graduated from Lawrence Tech, I actually was working at Lear Corporation. I did my internship at another company called Douglas & Lumison at the time, which is now been bought by one of the other competitors of ours. But I started out in manufacturing, and when I started this talk, that was a key part for me, and I can't emphasize this enough, that understanding how components are made is the number one thing that if you're going to leave here with anything today, that's it. If you're going to develop technology and you're going to develop components for any industry that's out there, you've got to understand what makes that type of technology. So for me, being in manufacturing, where I'd go out to the facilities and actually work on stamping tools and understand how parts came from the design table to go into, or computer, and go into and actually be physically produced through a tool, and understand what that die does to the metal, or what happens in an injection molding process, or extruded process, or a roll forming process, or a welding process. That's the stepping stone. And that was my stepping stone. And if I'm going to look at a success in my career, that was my number one success, because I was able to look at different designs through the 20 years that I've been at Lear Corporation, and in regards to engineering, see are they feasible, just from the get-go. And that saves a ton of time, and it saves a lot of money, because you don't have to keep going back and forth. Then the next thing is business. You need to understand the business. You need to understand what or how engineering affects the overall P&L of the company on that particular component or technology. You have to understand changes that, if they are incorporated, what's the end effect on the business. So not only do you want to be a strong technical engineer, but you want to be a business person. And if you can understand the business aspect and still have that solid technical background, that's a key for success. And at the end of the day, if I look at over the 20 years where I've gone through Lear Corporation, and I look at the people that I work with and see what their successes are, I would have to say those two attributes are probably the number one thing. Okay, and it doesn't have to be just in metal. It doesn't have to be just in plastic. It can be in fabric, it can be in foam, it can be, and I'm particularly talking about seat system components right now, mechanisms and things like that. Because I've had a multitude of jobs at Lear. I was, like I said, a manufacturing engineer. I was a program management. Okay, the program management aspect gave me how programs are organized, timelines to march to, understand issues and how they portray not only internally but also how they're portrayed to the OEM customer that I have to service, be that liaison between my corporation and the customer base, but then understand the financials of what I'm working on and how the different changes that are coming forward affect those overall financials. But to answer your question, the two main things, again, if I can leave you with anything, is understand how components are built and understand the business that you're in.